So how will you know which model to prefer, the active or the backup, or just evaluate models generally, beyond eyeballing the lines and looking at the beta parameter estimates? How can you evaluate competing models, is the question. Click Model Compare in the navigation menu. Model Compare provides diagnostics for the active and backup models side by side. One thing to note is that the dataset records is the number of records in the file you uploaded. Let's just change the size. Workspace records is the number of records in a workspace for which weight is greater than 0 and the transformed offset is a valid number. Now the size model is a good example of where the number of workspace records is less than the number of dataset records. Let's think of this intuitively, where there were 5,800 records in a dataset. A small proportion of those, around 23%, actually had a claim. So only 23% of those records could actually be used in the size workspace. Now, of the 5,800 records that were in the dataset, only 1,380 actually had a claim, as I said, so they could be used in the claim size model. Preddle knows to exclude those records that didn't have a claim, i.e. where the claim count was 0, because a log transformation was applied to the offset, and the offset was claim count. Now, taking the log of 0 is not a valid mathematical operation, so the records without a claim were not used in this workspace, and so were not counted in this workspace num records count. The total sum of squares down here is the sum across all records of the response minus the average response all squared. It's effectively the total variation in the response variable. Let's just change this back to frequency. Now the regression sum of squares is the amount of this variation that is explained by the model, and the residual sum of squares is the amount of variation remaining unexplained. The R square is the regression sum of squares divided by total sum of squares, effectively the percentage of variation explained by the model. However, the R square and the sum of squares values are really only relevant for normal linear regression, i.e. when you chose an identity link function and normal error distribution. For other model types, like what all of the model types in this insurance example are, these statistics are much less relevant and can be misleading if relied upon. The deviance is a much more useful measure of model fit for GLMs. The lower the deviance, the better the model fit. You can reduce the deviance by just overfitting the model. You can, using plenty of parameters. But this isn't good model practice, since it effectively fits to noise in your data. What you want to get is a good compromise between a model that fits well to the data with low deviance and a simple model with a low number of parameters. The AIC and BIC combine these trade-offs to give a more balanced view of model goodness. They take the deviance and add the number of parameters in the model. Now choose a model with a low AIC or BIC and you're on the right path to hitting a good compromise between a well-fitting model and one that isn't over-parameterized.